All right, here we go. So we are taking a look at what's called mole fraction, and it is exactly like it sounds. It is a fraction made out of moles, okay? So first thing I want you guys to do, grab your equation sheet, and we are gonna find mole fraction. You're gonna look for this symbol here, a big X with a little a after it. I want you to find it. And I'm having you guys locate these things so that you're not lost later and going, where's that equation? I think she said it was on here. We want to be able to locate them, get used to where they're at, that kind of thing. Make this a good reference. All right, did we find it? Yeah, it's on there somewhere. You're like, sure. All right, raise your hand if you found it. We got one. We got two. You're like, I don't know where it's going. This one's a little hidden. It's kind of weird. What section is it in?
Oh, it's at the front.
Oh, did you find it? The mole fraction.
Oh.
No, I didn't find it. Which section did you find it in? Yep, gases, liquids, and solutions. It's on the back. Right. It is this guy right here. Oh, there it is. It's in a weird spot. So I want you guys to find these things. So the way these are organized, we've got equations on the left, we've got constants and variables on the right. Now, they don't tell us that what X is. They don't say, hey, X is the mole fraction, which is rude, right? They should tell us what that is. But this is our equation for it. It is also involved in this equation when we get to gases and learn about pressure. We'll deal with that version of it. Okay, it's another way to deal with it. But the mole fraction is equal to moles of a chemical over the total moles. So we're going to put that equation on a paper here so we've got another reference to it. So when we look at this equation, you'll notice that this A appears in two places. What that A represents is any chemical. Okay, so we can replace the letter A with whatever chemical it's asking about in the question. So it might be, what's the mole fraction of sodium in this mixture? So we'd put X of sodium, and then we're looking for moles of sodium over the total moles. Okay, so that A can be replaced with whichever chemical we're looking for. So what is a mole fraction? A mole fraction is a quantity that compares the number of moles of one chemical in, or excuse me, where's my thing? One chemical to the total moles of a mixture. So we've got a mixture of chemicals. A mixture is something that has chemicals just hanging out with each other. They're in the same container. They've mixed up, but they have not chemically reacted and combined with each other. So an easy example of this is table salt in water. We still have table salt. We still have water. They're just hanging out with each other, making that solution. The aqueous solutions you guys made for your lab, the copper chloride and the sodium carbonate, those would be mixtures, right? They're homogeneous mixtures because everything mixes together, but they are mixtures. They're still just that chemical plus water hanging out together. If we dried up the water, we'd have that chemical left behind, okay? So we're dealing with mixtures, not reactions here. So to solve this question, or solve these problems, we're just gonna plug in our numbers. Now what's annoying about this and why I wanted to do this one together is that even though it's called a mole fraction, we do not leave it as a fraction. Because we're gonna have like decimal values that we plug into here, and that's a really ugly fraction. We're not gonna have like 2/3. It's not gonna be pretty. So we do have to actually calculate it and get one number for our answer. The other thing that's gonna happen is that we have moles divided by moles. So what happens to the units? Cancel. And we're left with no units, which is also weird and uncomfortable. I don't like it, but it happens. So let's take a look at an example here of how these work. It says, what is the mole fraction of sodium chloride in a sample of salt water with the following measurements? So we have 52 grams of sodium chloride and 150 grams of water. Could we plug any of these numbers into this equation right now? Thinking about the units. Seeing some no's? Why not? Because it's grams. So what do we need to do with them? Convert them to moles. Can we do that? Yes, we can. Let's do it. We got 52 grams of sodium chloride. Sorry, I didn't give you a lot of space. We'll shimmy it in there. All right, mass of sodium chloride. Sodium is 22.99. Chlorine is 35.45. We get a total of 58.44. Where should that go? Bottom. 58.44 grams of sodium chloride in what goes on the top? 1 mole of sodium chloride. All right. NaCl. All right. So let's find out what that is. We got 52 divided by previous answer. Do you guys know about the answer button?
Yeah.
You want to learn about the magic of the answer button? Okay, so I did the previous calculation, 58.44, so that's my answer. I got 52 divided by, if you hit second, and then mine is where the negative sign is, it says A and S for answer. It puts in the previous answer, and then you just press it. And you don't have to type as many things, yay! I know, teaching you how to use your calculator. One day at a time. All right, I love that button. Okay, so we get this lovely answer. How many sig figs do we get? 3. So our answer is going to be 890. So if we look at this, we got 89. Basically, we're going to round it to 90. If we think about that last part. I'm annoying. Okay, and that is moles of sodium chloride. Can we do that with our water? Yeah, I'm going to shimmy it in here. 150 grams of water. Anybody know the mass of water? So close. 18.02. Yep. 18.02 grams per mole. It's one you'll use so many times this year that you'll probably get stuck in your head eventually. We use a lot of water. 18.02. Sorry it's so teeny tiny. Do I need to zoom in or we can? Okay. All right, so we got 150 divided by 18.02. We get this. How many significant figures do we get? 4. So we're going to keep 8 point. All right, and your units? Moles of water. Okay, now that we've got everything in moles, can we start plugging things into our equation? Yes. So, if we look at this, our mole fraction, that giant X, it's asking for the mole fraction of NaCl, so we're going to put NaCl as our little label. Okay, we don't have to plug anything in there, it's just a label for us. So then we want to put the moles of sodium chloride on the top, 0.890 moles. And then what do we want to divide by? The total moles. So what do we need to do? Add them together and get our significant figures all squared away on that. We've got 3 decimal places on both, so that makes it easy. So what are we going to divide by? 2 what, huh? 214? All right, so we're adding these together to get our total moles on the bottom. So what happens to those units? They cancel out. So no units left. Boo. I don't like it. Makes me feel weird. Okay, so 0.89 divided by 9.214, and we get this answer. How many sig figs do we get? 3 versus 4. We get 3. Fabulous. Okay, do the zeros count?
No.
So 1, 2, 3,
9.
966. 0.0966. No units. Right? Once you've gotten units down, it's like, this is so awkward. All right. So this is our mole fraction. Well, what does it tell us? It tells us how much of this solution that we've made is sodium chloride. This is one step away from being a percentage, right? A fraction is part of something out of the whole thing. A percentage is part out of a whole times 100. So if I multiplied this by 100, I'd have 9.66. Basically, 9% of the solution is salt. So that's what this is telling us. It's a way to look at a percentage, way to look at how much of one chemical is in a mixture, but in moles in this case. So up above, when you guys were looking at this part, this is a mass percent, so it's using grams. Now we're looking kind of at a way to do it with moles. Okay, so a little bit different, but still works. So what I want you guys to do is I want you to try the next one. Same process. Try it out, and then we'll check it. Sound good? All right, so take a minute, work through that one, and then we'll check it. All right, were we able to find our moles of our two chemicals? Yeah. Okay, let's check our moles. Did we get that part? Question. You got your significant figures. For which one? Did you get 46.08 for your mass? Maybe you divide. What did you get? Did you get like 4 points? I think you divided the wrong way. You did 48 divided by 12.
Oh,
Yeah. There you go. I can always find a mistake. All right, questions on that part? Okay. Did we find our mole fraction? Yeah. Okay, what is your numerator going to be? 0.260. What's your denominator going to be? 11.4. If we round it to significant figures. I know, when we add things, remember it's decimal places. I hate that rule. It's really a bane of my existence and yours. But really, your number, it's your estimated digits, the one that's off. It's not bad. All right, so 0.0228. And then nothing because there's no units, which is really the worst part. Good job. All right, how are we feeling about this? Pretty straightforward. We're just kind of, it's another way to use moles. There's so many ways that we're going to incorporate moles into what we're doing this year. It's ridiculous. Okay, half these equations on your equation sheet deal with moles in some way. You don't even know. So, there is practice on this and the Avogadro's number and percent composition on the backside, on the next part of it. And then to round out and finish up section 1.1 is the AP Classroom, the first practice on there. It's multiple choice. I think this first one has like 8 questions, I want to say. Everybody in this class is on AP Classroom, so thank you for that. I had one in every class.